Hi everyone, my name is Manindra Parhy. I work at Nvidia. Today I'm going to introduce you to a revolutionary product from Nvidia called RTX VSR. I'm going to talk about the challenges we faced and how we made it a product at scale, what is the relevance to the industry, and where this technology may be going. But before I start, let me give you some background. 90% of the internet videos that are streamed, they're streamed at low resolution, like 1080p or lower. Many of these, maybe half of these, are like 720p or lower resolution. And at the same time, 90% of the people have 1080p plus displays. And even 30% out of that is they have bigger than 1080p display. Now, this creates a mismatch when the video is played on these larger displays. When the video is being naively upscaled and displayed, it creates a very blurry experience. And compounding to it this, there is the internet videos they have a lot of compression artifacts. This may be coming because they were compressed with an old codec like H.264, or this could be like there is not sufficient uplink bandwidth when someone is uploading the video to cloud, and so it needs to be compressed at a low bitrate. So this creates compression artifacts like blockiness, deep banding, and a lot of other kind of artifacts are there. Now, when this video is now oppressed, these artifacts gets amplified, and they produce a very poor quality of video playback. So we tried to solve this issue by creating a product called RTX VSR. Before I go into the detail, let me show you a video which will show a comparison between bicubic versus the RTX VSR upscaling. So what I'm showing here is a stitched video with bicubic on the left and RTX VSR on the right. As you can see here, the leaps and all on the right side is coming back very well. The stones and the rocks, they have a lot more details. And as the slider progresses to the center, you can see that like a lot of the details from the stones are coming back up. On this particular video, as you see, the deer, the fur is becoming more crisper. And in this one, the breeze, there is a wire on the breeze. That wire is becoming, it was a broken line before, now it is a continuous line and a very sharp line. And also some of the textures are coming back. Now in this video, you can see that the trees and are looking much better with a lot more details and a lot more vivid. And this is a gaming video. As you can see, the glove is basically like a lot of fine details are coming back. Let me run it a little bit further, and then I will go to explaining what RTX VSR is. So the RTX VSR is an AI network. It is used to generate high quality video from low quality equivalents. It has several components to it. It has super resolution, it has compression artifact, it has deep blurring. And the way it is learning this is learning the residuals compared to a bicubic version. So this picture will illustrate that. So let's say we start with a 1080p video, a 1080p frame. This is bicubically upsampled to 4K. Now the network has seen millions of images where it knows what is detail, what is compression artifact, or where the details is lost, and it learns these residuals. And when these residuals are added back to the bicubic upsampled frame, then it creates the crisper RTX VSR super resolution frame. So I will give you some more examples of the different cases I mentioned. For example, the old codec. So if you look at H.264, it creates like a lot of blocky artifact, as you can see on the lake. And also it creates a lot of banding on the sky. And the RTX VSR is cleaning all those those bands and making the blocky artifact go away from the lake, which creating a pleasing video. And also streamings can use very low bandwidth, especially with the 5G and all this. The bandwidth could be very low, it could be less than 1 Mbps. And this is an example of someone playing the game on a very poor network. And on the left side, basically, you can see like a lot of color patches on the floor, which is cleaned up on the right. The trees, you can see that on the left, it doesn't have much detail. It looks very patchy. And the right side is recreating those details. It is looking like a tree now. And here is another example. This video I captured from my phone. And when the phone is moving, it creates a lot of motion blur, creates the left side is a very blurry image. And RTX VSR removes those blur and shows it very sharp. So this technology is productized into our 30, 40, and 50 class GPUs. It enhances the video playback on the browser. We integrated into browsers like Chrome. And when someone is watching YouTube, Netflix, or Twitch, it invokes the RTX VSR. All you have to do is from the Nvidia control panel, you have to enable these features. And this is one of the very popular features that we have been hearing from our end users who are using our GeForce GPUs. Given the success of the video playback, we made it into a SDK so that third-party apps can take the benefit of it. They can, and the third-party app that's running on NVIDIA GPUs, they can call the SDK and they can take advantage of the RTX VSR. We integrated this as part of the VLC player. It has the RTX VSR, so you can download the libraries and you can take advantage of it. So how we productize this RTX VSR? The first thing is complexity. So while the AI cores have been progressing, the capabilities increasing day by day, but to come to this level of quality, it is just not sufficient. As I will be explaining on this chart, this shows the runtime of RTX VSR when it is upraising a 1080p frame to 4K. What is the runtime in millisecond? And we have 4 different modes of RTX VSR, which gives a complexity versus quality trade-off, because people may be using an older GPU, or they may be doing other things other than the video playback, so the GPU may be loaded. So we give 4 different modes, VSR 1 to 4, which comes at different quality and different speed. So if you look at the highest quality mode, it's like 35 millisecond, and no way it can be run real time on a RTX 4090. We did tremendous amount of improvement to bring this 35 millisecond to only 2 millisecond, which is a 15x speed up. The quality drop is negligible. And how we went to go about it is basically doing something called a layer fusion. So different kernels, they write out the output to the memory and creates a memory bound situation, which basically makes the runtime to be bigger. So we basically fused the kernels together, so the data doesn't need to go out of the chip to the DRAM. So, and also at the same time, we did the int8 quantization instead of FP16, then it reduced the memory bandwidth and made it much faster. So basically the black line here is the PyTorch, and the blue line is basically our custom optimizations, followed by the green one is further int8 optimization. So perf is one aspect, but the even bigger thing is the quality. So how do we get to this level of quality? It starts with a high quality training data set. There are a lot of training data set out there, but they have their copyrights and all. So what we thought is that we will go and capture our own videos. So with a phone, we captured the videos, we captured gaming videos ourselves, and then we put this into the training. And as you know, it's very critical for an AI network to be successful. The training data has to be right. The next thing is we have a very well crafted, put a lot of innovation into the data augmentation and how we train using the loss functions. So that was the second step. And once we have this network in place, we rely to some degree on the objective metrics like LPEPs and all that. But as you know, today's objective metrics are far from matching with or correlating well with human visual system. So then we instead of what we thought that okay, if that's the stumbling block, why not do a actually rely on human vision system, do intensive subjective evaluation to get this right. So we put the millions of images that we looked into very carefully to see that where the network is performing good, where it is not. So it is easy to create a network that can work well generally, but it's very very hard to say that okay, it is robust enough that it can work with any different scenarios. Maybe it's a close up of a human face, maybe it is a nature video or other kind of videos. So there needs to be, it needs to be really really work well. Otherwise few cases of bad things, bad quality can throw up people. And this will be apparent to you on the next slide, where how we made this quality progression. And on the left side there's a bicubic image, and the middle one is the first person we created. And as you can see on the face, like generally it was working good in let's say 90% of the cases, but there were some cases like this where in the face the details were gone and it looked like the as if somebody has basically removed like used a razor or something on the face, which can throw up somebody, and it's not good. So we spent a lot of effort to make sure that the quality is good enough. As it can see on the right side, it has removed a lot of patchiness from the bicubic, but at the same time it has preserved the details and all it, and it's looking very natural. So after the success of RTX VSR as a video playback solution, we thought that can we use this for different kind of use cases and scenario. And we are pleasantly surprised to see that this is working very well in many diverse set of applications. I will give only some few examples. There's a lot in the works, and we are seeing every day we are discovering that it can improve many of the video use cases. So two of the examples I'm going to talk about is the GeForce Now, which recently was announced as cinematic quality mode, and a collaboration I will illustrate with Cinefilm, a global leader in image processing, to improve the broadcast quality video. So the GeForce Now Gaming, we introduced this cinematic quality streaming mode. Let me just show the picture. And on the left is the standard encoding. So GFN is basically, or GeForce Now is when people play games on their not so powerful laptops, and the rendering is happening on the server. And then it's encoded and streamed back to the player in real time. So here, because of the gaming has a lot of sharp edges and all, then those traditional codecs are not good with that. They take a lot of bits. Then there is starving the other part to be not have enough bits, which creates this kind of patchy look. And we just reversed the problem. Instead of doing a post-processing, we applied the pre-processing to encode the render games. And the right side is the example of that, where we are getting very high quality, and it almost looks as good as if it was locally rendered. So it has cleaner motion, less noise and artifact, and people are going to enjoy the GeForce Now with cinematic quality streaming. Another point to illustrate is Cinefilm. They are a global leader providing image processing solution to big names in film and television. So they are using our RTX VSR technology to improve the content from multiple camera sources at major event, or enhancing the legacy video libraries and making it ready for modern delivery to the TV channels. So these old videos are being improved by using the RTX VSR. And here I will show some quotes from them. They published a blog. What they're saying is that from the existing solution they have using RTX VSR, they are getting the quality and detail enhancement to a degree of 25 to 35% better. And They're using their own motion compensation and noise management know-how and combining with RTX VSR. So to sharpen, intelligently sharpen, to sharpen, to decide where to sharpen, where to less sharpen, and pres- producing a cinematic quality at scale. I will show you some examples of that. The image on the left is an old video from old footage, and you can see that this is very, very blurry, and using RTX VSR, it comes alive and it looks like captured today. And I will show you another example where the left side is again looking very blurry. The text and all are looking very blurry, whereas the right side, the text jumps up and the whole thing is looking, it's like putting a lens back on. Somebody has a vision problem, you put back your glasses and looks sharp and clean. So that's the effect we are getting. So future direction. We see that like a lot of companies are investing in the super resolution area. So it naturally makes sense that it will be part of the video standardization someday. We are happy to collaborate. And basically the what's happening here is every 5-6 years there is a new video standard coming, but these are using the classical signal processing algorithms, and this is becoming very hard to get visual gain, and also it comes with significant complexity, which can be which is not sustainable to put all these different codecs into the hardware chip. So at the same time, most of the platforms going from server to mobile, they have AI accelerators, and they are there irrespective of whether you do video improvement or not. They are there for all kind of general purposes. And if we can do this kind of AI based post processing technology on those AI cores, then everybody can benefit out of that. So we expect that in the future all this technology will be part of the video standard. So that was my last slide, and thank you very much for listening. I hope this is of interest to you, and we can, if this can help you in some way, then let's collaborate to use the RTX VSR using Nvidia AI cores and enhancing your application. Thank you very much.